I was gonna say, when we borrow, if there's a whole, well, do we always take away from the whole, or do we also turn the 8 into 18 and then subtract?
No, we always take it from the whole. Thank you for asking that question.
So, what do we do if there is no whole?
Then that fraction will be a negative number. You will learn
Uh,
that in sixth grade. Okay, right now we don't learn negatives, but it's in fifth grade right now. It's kind of impossible. Okay, but in math it is possible. You just be in a negative. All right, so now I'm gonna borrow $1 from here, but I'm gonna exchange it for coins. Instead of having a dollar bill, I'm gonna exchange it for coins. So I'm gonna add this back right over here. And here's the dollar. I call it my fancy dollar. Okay. This is the only time in the history of fractions you're able to choose your denominator. Okay. You actually, at this point, because you're exchanging it for coins, think about it. When I change my dollar bill for coins, I get to choose, I get to tell the clerk, can you exchange this for 25 cents? Or can you exchange this for dimes, which are 10 cents, or nickels or pennies? Make sense? So you get to choose how you change out this $1 bill. And the smart thing to do is to choose what the denominator already is, so you don't have to think about the denominator. So what is our common denominator at this time?
12.
Go ahead, Logan.
well,
It is 12, so it is smart for me to choose 12 as a denominator. Okay? Now, that gives me half of what I need for here already. So what over 12 will give me a whole?
12.
12 over
12.
12?
Yes. Okay. So anytime when you have a fraction, if your numerator and your denominators are the same, that's one whole. Okay. So notice all I did was I exchanged one of the $2 bills that I have for some change. But in the change, I can actually request, I can actually choose what denominators to use. And because I'm working with 12s right now, okay, I'm choosing 12 as my denominator. Once you chose that denominator, as you can see, in order to make it a whole, we have to have the exact same number as the numerator, okay? That's a lot of steps. Let me get back to my board to see if you guys can still see this. Sorry. Okay. Okay. So now what we need to do is we need to add all these coins that we have together. But as you can see, we still have 12 as our denominator, so that 12 can carry over. Okay? But now we have more coins right here to add into the existing coins that we had. So what is 8 plus 12?
8 plus 12
20?
is 20.
It is 20. Okay? And here's what I want you to do to make your work look cleaner. Circle that 20 and X out everything right here. Okay? Not the bottom fraction, but just the top part of it. Because that's a lot of numbers to process. That's too much. Okay? So now I have 20 coins. Can I give Logan 9 of the 20 coins?
Yeah.
Yeah, I have more than enough to give Logan 9. Okay?
Where,
Yes.
where did you put 20 at? Because for me, it just says that your expo marker is just stuck. It's not even moving.
The 20 goes on top of the 12. Okay. Can you refresh your page, Logan?
Refresh my Teams.
Your page? Yeah. You can't refresh it, huh? Is it still frozen? Oh, we lost connection. Okay. It's all right. Okay, so now what is 12 minus 9? So now all we have to do is just take this numerator and we're going to subtract it by that numerator. So let me see. Jeremiah, what is 20 minus 9, sweetie?
And that
You're muted. Did I put you on the spot, Jeremiah?
Yes.
Yes. Do you need help? Okay. I'm gonna call for help, okay? Slade, what is 20 minus 9?
11.
All right, so we have 11 as our new, hang on. Okay, we have 11 as our answer right here, okay? But don't forget about the wholes. We have 1 minus 1, which gives us 0. So at this point, okay, if I had, I don't know, 2 and 2/3 of a pie, and I shared 1 3/4 of that pie with somebody, not share, but like gave it away, okay, what I have left is 11/12 of a pie.
Mm-hmm.
Any questions?
No, man.
What is the fourth step that we need to do? Go ahead, Xavier.
The fourth step we're gonna do is we're gonna what's called simplify it, I think.
Yes, we simplify or reduce. And I will give you a little trick, okay? Remember prime and composites?
Yes, ma'am.
Okay? 11 is a prime number. Okay?
So
11 is a prime number. So the only way you can reduce this fraction is if the denominator is divisible by 11. Let's look at our chart. Our chart has 11, and then it jumps right to 22. It doesn't have 12. Okay? So that tells you that 12 is not divisible by 11. So these two numbers have nothing in common with each other.
So
Okay? You cannot find a common factor, so it is already reduced. All right? Okay, any questions? Any questions?
I have a question.
Go ahead, Logan.
When I left teams, you were explaining how y'all got. I did not understand how y'all got 11.
So you asked where do we put the 20? The 20 went up here because we added 8 plus 12 gave us 20. So now we're going to cross all of these out because we kind of exchanged all of these coins. We combine all these coins together to get that massive new combination of coins. Okay? And now we're going to use that new number and subtract it by 9.
So you add the top of it to the 12, and then you go from the 20 and you subtract the 20 by 9.
Yes, by
So
the
you kind
bottom.
of make like a triangle.
Well, we're not really making a triangle or anything. We were just solving for what's on top, and then what's at the bottom, we subtracted, right? Just like how we normally did it. You have a fraction on top and a fraction at the bottom, and you subtract them because our operation is subtraction. That's all.
Okay.
Okay? Let's work out one more problem. I want to give Addie a chance to copy this down. Addison, are you able to copy this thing down, sweetie?
I'm working on my leg right now.
Okay. So, okay, tell me when you're done, and then I will erase it, and we'll start with our next one.
I'm just writing 11 and 12. And that's it.
Wow. Okay, you're fast. Okay, here's our number 2. A lot of it right now, because this is so new to you, you may not get it all, and it's okay. Okay? As you work with it a little bit more, you get more familiar with it. Okay, next problem. Number 2, we have 3.5 minus 2 and 2/3. Okay, I always set up my fractions problem like that.
Can I say what the first step is?
Sure, what is the first step, Logan?
You have to find your common D, so you have to put your 2 and your 3 on a T chart. and then you have to try to find which one matches like which number.
So what are some of the multiples for 2's?
4,
What's next?
6,
Perfect. Okay. What to do next?
then you can go to your 3 maybe.
Okay. So we have 3, and then what's the next multiple?
6, so and there's 2 6s after 3, so now that we have our common D, which is going to be 6, so we put it under all the lines.
Perfect. Okay. For those of you who have the multiplication chart to use, the common D is actually pretty easy. You actually don't have to write this down. What you do is you put your fingers on the 2 numbers that you're talking about. So I have 2 and 3 right here. Okay, pay close attention, because some of you I know have a multiplication chart that you can actually use in class. Okay, so what I do is I would just slide my finger on the smaller number. Okay, and here's what I do. So here's the thinking process, the thought process that goes into this. Can I turn a 2 into a 3? Nope, not here and not here. So I stop right here, and I'm gonna slide down my next number on the 3, and I say, can I turn a 2 now into a 6? Yes, I can. It's right here. There's a 6 in both of these, okay? And that's how I can choose my common D, which are in here. Perfect. Okay, can someone else tell me the next step? Kira, what is the next step? Kira Poo, what's the next step? Okay. Xavier, what's the next step, babe?
We find the numerator.
Okay, so we find the equivalent fractions to this, okay? So how do we find it?
We times it.
Okay, so did you notice that when you put the 6 right down there, you actually done half of the work to find the numerators, or to find the equivalent fractions already, okay? So now the thought process is 2 times what makes 6?
3.
So Xavier, it's 3. So whatever you do to the bottom, you're going to do to the top. So what is 1 times 3 now?
3, 6.
It is 3. Okay. So again, Xavier, 3 times what makes 6?
2.
It's times 2. So whatever you do to the bottom, you're going to do to the top. So what is 2 times 2?
4, 6.
4, 6. Okay. Now we have another problem. Our operation is subtraction.
You're going to have to regroup.
So Kennedy, 3 minus 4, can we do that?
Nope.
Nope. Okay. We have to borrow the $1 from this 3 right here. Okay? And how are we going to give back that $1 right here, Kennedy?
Okay, by 6. Six over 6.
So what denominator should we choose? This is when we actually get to choose. What is a smart student? What should a smart student choose?
6. 6.
Hang on. So Logan is saying 6. Do we all agree that 6 is a smart choice?
Yes, because it's the denominator.
Yeah? Okay. Yeah, it is a smart choice because we're working with 6 already. Why don't we just choose 6? Okay. Sine, do you have a question, babe?
Yes, I was copying it on that top with the 6 on it. Is it supposed to be like around? Like I couldn't see because the top.
Oh, it might be just my fancy 1. I tried to make a 1 like in a box. I call it my fancy 1. Sorry, my camera was covered. Okay. Thank you, ma'am, for letting me know. Okay. Yes. Hang on, Sine, I want to ask you. So if we chose this as a 6, what number should go here in order to make this a one whole?
Number 3.
If a 3 goes up here, then it will be 3, 6. Let me draw you a picture. Okay, if this was a Kit Kat bar, and I have 6 pieces in this Kit Kat bar. If I ate 3 pieces, I didn't eat the whole bar. So how many pieces should I be eating? Perfect. Okay, the top number has to be exactly the same as the bottom number in order for us to get that fancy one. It's not that hard. It's just a rule we have to remember. Okay, and if you don't remember that rule, draw yourself a Kit Kat bar. Okay, ask yourself, if I had a Kit Kat bar with 6 pieces, how many pieces do I need to eat in order to eat the whole bar? What you're going to see that you're going to color in all 6 pieces. Make sense? Okay? There's nothing wrong with drawing in math. All right. So now we have some new coins. I will. We have some new coins that we can add together. We can group them together now. Okay? So, Addie, we know that this is 6, so we're going to keep it as a 6. What is our new numerator now after we added the new change that we got?
Can you hear me?
Yes, ma'am.
So it's both 6, right? Our
It's
new
3
denominator.
plus 6.
3 plus 6 will be 9.
Okay? That was easy, right? Did you notice how the 6 just stays the same? So the only thing that changes is just that numerator. Okay? So now that we got this new number of coins, I can cross these out because it's just too confusing for me. I just like to cross them out so I can make my work looks cleaner. Okay? So now the only 2 numbers I should concern myself about is that 9 and 4. So now I have enough change. We have enough change, right, Kennedy? To give 4 away, right? So what is 9 minus 4, Kennedy?
5.
Yeah. What about the whole numbers? When we subtract 2 and 2, what do we get? We get what?
0.
0. Okay? The 0, you can put a 0 or you can ignore it. It's okay. In this sense, the 0 just represents I have no paper money. I have no whole dollars. I just have change. Okay? Now let's look at simplifying this. Well, again, 5 is a prime. Remember that? 5 is a prime. So remember that. If you look on the chart, can we take a 5 to a 6? No. Then the only way, okay, when the numerator is a prime, the only way you can simplify this is if the denominator is divisible by that 5. In this case, 6 is not divisible by 5. So we are already simplest form right here. So this is our final answer.
5, 6.
Questions?
No.
No,
Okay.
ma'am.
Perfect. We have a lot of time. So let me go ahead and give you an example of a problem that we had on the test today that I felt like it was really extremely difficult. Of course, I cannot give you the exact same problem that's on the test, but I'm going to give you something like it. So tomorrow, for my Team Tulane students, that's the virtual students, if you are taking the test, you can rethink of the process. It's not going to be exact same numbers, okay? But just rethink the process. Okay. So, can I erase?
Yes.
Yes.
Yes, ma'am.
Thank you. You guys are so great. Thank you, guys.
Welcome.
If you were here, I'd give you popcorn. I'd give you juice because I love your learning attitude. That is so awesome. Okay, so the question says, a farmer had 60 acres farm. Okay, so here's his farm. You guys don't have to, actually, you can draw this down. Here's our number 3. Just draw it to understand the concept. Okay, So the question says this farmer, we're going to give him a name. We're going to call him Mr. Xavier. Okay, he had 60 acres of land. Okay, and Xavier is going to use 3 3/4 of this land to grow, I don't know, corn. Okay, and then he's going to use another 10 and, I don't know, 2/3 to grow some vegetables. Okay, and the rest of it he's going to use as just bare land. He's going to let that land rest. Okay, now the question is asking, how much bare land does farmer Xavier have? Logan seems to have an idea. What do you think we should do in order to figure out this problem?
I think it's gonna be a problem where you have to add and subtract. So first, what we should do is we should find our common D for 10 and 2/3 and 3 3/4, and then after we find our common D, we should like add it all together and see what we get. And then when we get our answer, we subtract it by 60, and when we subtract it, we will get our total to what we have left.
You are absolutely right. So let me show you how this number sentence looks. Okay, so what Logan is essentially saying is that I see that his total land is 60 acres. And he used some of it for corn and he used some of it for vegetables. So his bare land right here should be less than 60. And because it's less than 60, okay, we know the operation is to subtract. So you can actually write this as a number sentence that kind of goes like this. Okay, and what are we subtracting? We're subtracting the total amount of land that he used to grow some things. Okay, so here he used this much land to grow vegetables, and then he also used this much land to grow corn. Now, have I lost you guys there?
No.
No.
Still good. Okay, so this is where what Logan was saying comes into play. Okay, she's saying, let's go ahead and add these two, and then we're going to subtract whatever this answer is, we're going to subtract it by 60. Okay, so let me go ahead and erase so I can have more space to rewrite the problem and set it up properly for you guys. Because I apparently do not have enough board space. Okay, can I erase?
Yes.
Okay, so here we go. Step 1, we have to find the total land that he used to grow stuff. Okay, so I'm going to rewrite it in this fashion. That way it's easier for me to see how to do this. Sine, what's the first step? Does anybody know what the first step is?
I do.
I do.
Who just said I do?
Me, Kennedy.
Okay, go ahead, Kennedy.
In case the three and four, but we can do, but we can know what but we can multiply 3 and 4.
Yeah, so what's that going to give you?
12.
12. Okay, so what Kennedy is saying is that we have to find that common D. Because it's common D, we can put it in 3 places. Let me show you how I can find that on the chart. I have 3 and I have 4. Okay, remember I always move my smaller finger first. I'm going to ask myself, can I turn a 3 into a 4?
No.
Okay, There's a 3 here and there's a 6, so I can't turn it into a 4. I'm going to slide one more. Can I turn a 3 into an 8? Slide down. Nope, I can't turn it into an 8. Okay, so one more down. Can I turn 3 into a 12? Yes,
Yes.
I can, because they are the same right there. So I'm going to put 12 in all 3 places. Okay.
So 4 times.
So 4 times what equals 12?
Mhm.
4 times 3 equals 12, so then that'd be 3 times 3, which would be 9.
Thank you. Kira, are you back with us?
And then, wait, oh, never mind.
Kira, baby, are you back with us yet? I have a feeling she's frozen. Okay.
Yes.
Oh, wow. I've been calling on you, sweetie. So what do we do next?
You have to find the top numerator.
Can you help me?
You have to do 2 times 3.
So are you telling me that 3 times 3 is 12? Because that's what you're saying right here. If we're multiplying this on top, we have to multiply the same
3
number at the
times
bottom.
10.
Huh?
3 times 10.
3 times 10 will not give you 12. Here's my chart. 3 times what gives me 12? 12 is right here.
4.
Thank you. 3 times 4. Make sure you use your chart, okay? So whatever I do to the bottom, I'm going to do to the top. So what's my numerator now, Kira?
4, 6, 8. 4.
My numerator is 2 times 4. So what is 2 times 4?
4.
Try again, Kira. 2 times 4 is not 4. So I have 2 times 4.
8.
It is 8. Okay? Whew. I'm lucky. I'm actually adding this time. I'm not subtracting yet. So adding is easy, right? So what is 8 plus 9? Slade?
9 plus 8 is 17.
It is 17. Okay? Now, I cannot forget about my 10 plus 3 either. So Slade, what is that?
Did you say 10 plus 3?
Yes, right here, my whole number.
Okay. 10 plus 3 would be 13.
It is 13. Okay? But this one is also improper, so I have to change it into a proper form. Okay? Now, let's go ahead and break this apart so that it's proper. Do you agree with me that we're working with 12, so I can make 12s right here?
Yes.
Okay? So in order for me to make one whole, what numerator do I need to make this fraction a whole?
12.
I need a 12. Whatever at the bottom, I need it in the top to make it a whole. Okay? So imagine this. You had 17, okay, marbles to begin with, and you used 12 of them. How many marbles do you have left?
Wait, what?
If you started out with 17 marbles, if you started out with 17 marbles and you used 12 of them, you gave 12 of them away, how many do you have left?
0, so you have to build, you have 0 left, so,
So 17 minus 12 is 0?
No, 5.
oh no, 17 minus 12 is 5.
You're right, okay? So right here, 17 over 12 actually means 1 and 5/12. Okay? Make sense?
Yes.
Okay? So now I'm going to add these two together. because I still have that 13 that I was worried about. So 13 plus 1 is 14. That's easy. And then 5 twelfths. Again, 5 is a prime number. So I go ahead and I'm going to ask myself, 12 divided by 5. Can I do that?
No.
No. So this is already reduced. You don't have to simplify this. Okay? Are we good?
Yes.
Okay.
I can't see your screen now. It says just your icon.
Okay, let me go ahead and unshare and share again so you can see it again. Now the next part is actually, it's not hard. It just requires you to look at the number a little bit differently. So make sure you pay attention to the next part, okay?
Okay.
And I think this may be the last problem we have, unless you guys have other questions that you guys want me to answer for you. Okay, so we know that the total that we have for Xavier's vegetable garden is 14 and 5 twelfths. Okay, can I erase?
Yes.
Slade, are you good? Can I erase?
Yes.
Okay, so now here's the second step. In order to find how much land he left as just bare land, we have to take his total, which was 60 whole, and we're going to subtract it by 14 and 5 twelfths. What is wrong with this picture? Can somebody tell me what is wrong with this picture? Addison?
Yes, ma'am.
What wrong with this picture right here?
It says so it has a 6 and a 0
Uh-huh.
and stuff, but there's no. I'm sorry, my dogs are barking.
No worries.
Um, she's at work. She's at work. Full. The thing is, it's just a 6 and a 0. There's nothing to equal it to besides 60.
Okay, so Addie is saying this is a whole number and nothing else. And then we have a whole number and some fractions.
Wait,
So how are we going to do this?
I think I know.
Okay, I'm going to, Xavier, because I explained this in class to you already, I want to hear what Logan has to say. Okay, go ahead, Logan. What do you think we
Okay. I might be wrong, but I'm going to try this. Okay, so I think we should do 60 minus 14 first, because those are our two whole numbers. And since we have two whole numbers, we should probably do those first. No, wait. We should try to turn 5 twelfths into 12 twelfths by taking away the 14 and taking away some of the 14s and taking away 7 wholes from the 14 and then subtracting 60 minus 7 minus 12.
You're complicating matters. You were on the right track, but you were doing it with the wrong number. Okay? So here's what we need to do. We do it exactly the same way as we've been doing it with the last two problems. Even though so imagine again that here are $60 bills. Okay? We're going to take 1 away from it. So what is 60 minus 1?
59.
It is 59, okay? And we're going to exchange that 1 that we took away with coins, okay? We no longer have that 1 as a whole anymore. We're going to exchange it in for coins. What denominator should we use? Should
12.
we choose? This is where we can choose, okay? So we have to choose wisely. Because we're working with the other denominators, 12, why don't we choose 12? That is the smart way to do it. You can choose other denominators, don't get me wrong. But then you have to find the common denominators for that, and then you have to do all of that process, okay? If you get to choose what's easiest for you. And 12 is the easiest for us. So if we chose 12 as a denominator, what should our numerator be in order for us to make this a whole?
How do you get from 12 to 12 and you multiply 1 and then 5 times 1?
Not yet, honey.
Oh.
Okay. I still need this numerator. What should this numerator be?
12.
It should be 12. Okay. In order for us to make that fancy one, The top and the bottom has to be exactly the same numbers. So did you notice our denominators are already the same? So now all we have to do is just subtract those numerators. It's that easy. Okay? It just takes you to see numbers a different way. Okay? Especially when you're working with fractions. Think of it as like dollar bills and coins. Fractions are your coins, and whole numbers are like your dollar bills. Okay? So I have 12 now. I have 12 minus 5 now. I have enough to subtract, right?
Yes.
Okay. So what is 12 minus 5?
7.
Okay, thank you. And who can do this math really fast for me? What is 59 minus 14?
45.
Go ahead, Xavier.
45.
45. Okay?
45.
Yes. Again, we're going to ask ourselves, remember 7 is a prime number. You know, knowing your primes really helps with reducing fraction because now you don't have to try it. If you want to, you can. You can show your work by making the t-charts. But let me show you 7. The only way to get to 7 is 1 times 7, nothing else. That's how you know it's prime. Okay? So the only way you can reduce this fraction is if this bottom number is divisible by 7. Unfortunately, it's not, right?
Mm-hmm.
Yeah. If this was 14, then yes. Okay, but this is 12. Again, if you want me to show it to you, two numbers that you can multiply by to get to 12 would be 1 times 12, 2 times 6, or 3 times 4. 7 does not exist in this chart. Okay? And they don't share any common factor. So therefore, this number right here is reduced.
So our answer was 45 and 7/12.
Yes, ma'am.
Okay, thank you.
You're welcome. Any questions? If you don't have questions, you can leave. Okay? If you have questions, I want to be here for you to ask. Okay. Kennedy, you doing okay? Okay. Good. Bye, sweetie. Addie, can I speak with you, honey?
Yes.
Okay. I'm gonna wait until everybody's gone. Xavier, do you have a question, babe?
No,
Bye.
I'm gonna see what I got on the test.
Oh, okay. Bye, Kennedy. I haven't graded your test, babe, so tomorrow morning I'll try to get those ready for you, okay?
Okay.
Okay, thank you.
Thank you.
Thank you. You guys are doing a fabulous job. Bye, sweetie. I'll see you tomorrow.
Bye. See you tomorrow.
Bye, sweetie. Mr.
Bye
Jeremiah.
bye.
Bye, babe.
I had a question. Wait, I
Yes.
had a question. How did I get 4 instead it was 11? I thought it was 4.
Which one are you talking about?
Number 2 or 1?
Number one.
Yeah, number 1.
Number one, the final numerators that we were supposed to subtract was 20 minus 9.
Oh,
Okay? So that
But-
gives you 11.
okay. Bye.
Bye, babe. Make sure you make up all your missing work. Okay. All right, Addie, can you turn on your camera or no?
I'm on my phone, so no.
Okay. So let me stop recording.